Okay, welcome to chapter number 9 of the server and vServer performance optimization. This is second to last chapter. This one is a little longer than the previous, but not too long. vCenter is an important aspect to this entire infrastructure. It needs to have plenty of resources to run effectively and quickly to handle all the complex systems that it oversees. By itself, you have the vCenter server and its services, and the platform service controller. If any of these are eating up too much resources or don't have enough resources, your entire database will suffer. As you can see here, there's a lot of communication that happens between the two main services that comprise your management node. You have for the end user, the web browser. To that, the vCenter server has to have the service vSphere UI running, which is connected to VPXD, which is connected to another service, interconnected to a database with a couple others. Through VPXD, it also communicates directly with the physical hosts. The UI can connect to single sign-on services like Active Directory. And VPXD also connects to other directory services. All of this is not any lightweight tasks. This is actually a lot of heavy, intensive programming that will be done in the background in order to ensure that your systems are fully functional and you get the full extent of what vCenter can do. Considering a number of factors that you need to monitor and maintain acceptable levels of performance, you have the platform service controller itself, the number of concurrent vCenter server operations, CPU and memory, network, database, and user interface. So starting with platform service controller, the default for it is 2 virtual CPUs and 4 gigabytes of memory. Unless you're dealing with larger systems, that should be sufficient. If you have separate nodes, you're going to have that same separate configuration everywhere else. Ideally, you want the latency between your platform service controller and your vCenter servers to be less than 30 milliseconds, because a lot of this happens quickly, and a lot of this is automated, as you have seen in the various chapters that we've covered. So high-speed communications is essential. The hard limit that vCenter has is 640 concurrent operations before a new request is queued, and 2,000 concurrent sessions allowed before requests are rejected. Now, if someone in security, you see those, then you would create ways to deny the service, those services, and reach those numbers so that everything else dies. As a general guideline, your CPU performance should not go above 70%. If it does, then we probably need to add more CPUs to the vCenter server or add another instance to load balance across instances. This system does use Java, and so if you see it consuming a lot of CPU, you'll need to increase heap memory size for that service. And of course, any plugins that you add to the system later will also contribute to CPU usage. Memory will follow the same guideline of it should not go above 70%. If it does consistently exceed 70%, then check vCenter swapping, check which services are using high CPU and which ones are using a lot of memory, and then add more memory as needed. You can see in your appliance management or within the VM's own graphs, see the usage of CPU and memory. And again, if it's above 70, if either one is above 70, consider adding more memory or seeing why it's using that much memory and rectify that issue. You can use vimtop as well to monitor resource usage, just like ESXtop. You see the processes, you can dig in deep. You can also do the same with a vCenter's own graph system. Same with this, showing you what process is using how much resource. And here's a quick question. It's a general guideline which you should keep CPU and memory usage by a vCenter server instance below which percentage? The answer is 70. Again, just like CPU usage, you can monitor memory usage using a vimtop as well as the GUI method. We can also view the amount of memory allocated to a vCenter server service with Cloud VM RAM size. And it'll tell you how much RAM is being used for each service. The heap size can also be brought out with a -J for several Java services. And then to change it, it would be in this manner. You don't have to reboot, but you can individually resize a service. With this example, we see that the vSphere client has now grown to 700 megabytes. Your network. Host-to-host bandwidth is typically more critical than vCenter server to host. In most cases, operation latency is bound by the host latency. Your vCenter server database will always play a critical role. So minimizing that latency is important. If you are using a Windows vCenter, so if you're just using an external database to be the database for ESX server, you'll see some of these guidelines could apply. If you're using the built-in appliance, then it's already embedded into that, so you don't have to worry about latency if you have it. If you are using the OVA file turned into an appliance. So again, if you're running a database outside of vCenter, like a custom built or running a database on a different box, you would use these something like this to view the network activity and see how many packets are being dropped between vCenter and the database. And you want to minimize the latency, minimize the number of drop packets, because again, it's highly important that vCenter can easily communicate and quickly communicate with the database. Under normal vCenter server usage, your resources like CPU, memory, disk, and network should not be saturated. There is going to be some transient high CPU usage during a rollup or an update. Those are not a problem, but consistently high CPU usage is not normal. Again, things to worry about if you have a database separate from vCenter. Using external, you could use tools to like recompute the database statistics, to purge database tables, to check, like verifying queries, seeing where is the slowdown, to fix that so that your database will work as fast as possible. When you're changing some settings, make sure that everything is functional. You want to make sure that the network counters are increasing significantly, that you see that there is a positive change in the communication between vCenter and the database. If you've ever taken out that appliance and you see that it has a number of disks and you wonder why does it have so many disks, this is why. The first disk is the boot and the swap. The second is the temporary. The third is another swap. The fourth is the core dumps. The fifth is the log. 6 is database if you're using the built-in. The database log, seat, net dump, auto deploy, image builder, and archive. This is good to know. Should something happen with the appliance and you want to get the logs, you would specifically look for VM DK5 and get the information off of that. You can use VAMI to monitor disk usage by each partition if necessary. I have seen where the older versions of the appliance will eat up all the log file space and then it prevents everything else from working. So I would suggest to keep an eye on these hard disks and make sure that they don't fill up, because once it does, vCenter acts really slow. Services are just all over the place. It's just not a good, it's not a good day. Of course, you can monitor disk usage directly and use vimtop as well. SEAT, if you were wondering what that stands for, it's stats, events, alarms, and tasks. And here's a question. Host-to-host network bandwidth is typically more critical than vCenter to host bandwidth. And the answer is true. A second question. Which of the following tools can you use to monitor the free space in vCenter server database? And the answer is the first and the last. That is the end of Chapter 9.